So last video, we dealt with the introduction to geometry. Basically, we introduced geometric objects like lines, rays. I think we talked about perpendicular and parallel lines. Like, at least, like, the vocabulary and how you can assume. And we talked about how to name, like, angles and all that stuff. But now we want to get into the more technical stuff. This is the stuff you will be using more often. Like, that was a good introduction. Geometry and what it's about and the type of topics. Now, chapter 1, which we are in right now, is primarily focused on line segments and angles. Because in chapter 2, depending on your curriculum, of course, chapter 2, you're going to be focusing more on proofs. You start proofs, and those proofs are going to be focusing on segment and angle proofs. So, why don't we learn about, why don't we first learn about segments? So, let's say we have this segment. Pause the video for a second and write out some ways you can name it. Okay. So, you can name this segment A, B, or B, C. You also could have said A, B, or B, C. No, you can't. Well, this is for measures. I asked just how to name the segment itself. But that's how you would name, like, the measures of the segment. Or the length of it. So let's talk about our first new vocabulary word. A midpoint. This is just what it sounds like. Middle between 2 points. And then there's a little more to know. That's everything you need to know about a midpoint. So I'm actually going to delete this now. So we can focus primarily on some stuff about a midpoint. So I'm going to draw my best attempt at a coordinate plane. That was like the worst attempt ever. I'm sorry. So, here. So, it's just a midpoint is the middle between 2 points. Also, on a line segment, if you have a midpoint of a line segment, it cuts it into two perpendicular, two congruent smaller segments. So let's say we have 2 points. So let's identify. So this is x2, y2, and there's a reason why I'm using x subscript instead of like the values. We probably should use values, though. I'm gonna need the values. So now the values are. Let's just say that's 4. So 5, 4. That's 1, 2. So what if you were asked to find the middle between points? So there is a formula for the midpoint of 2 points on a coordinate plane. So let's say M is the name of the midpoint. M equals x2, x1. So what you're basically doing with this formula, you're taking the difference of each value and you're adding up both of the values of it, and then you're dividing it by 2. So that's how you find the midpoint of between 2 points on a coordinate plane. So quick diagram real quick I'll try to make. This is x1. Like, this is my good attempt. This is a great attempt, guys. And then we have y1, x2, y2. So that's what it looks like, if you're curious. So now let's plug in the values of the points to define exactly where our midpoint will be. So 1, 2, and 5, 4. 2, 3, 4, 5. 3, 4. Yep, 5, 4. So now we plug this in. So first add the x coordinates. 1 plus 5 over 2. We add 4 plus 2 over 2. This brings you 6 over 2 and 6 over 2. And you know that just means 3, 3. So those are the value of our midpoint. So now we can plot this down on the coordinate plane. 3, 3. So that's right here. Yay. 3, 3. And this is our midpoint M. So we've officially just found the middle between 2 points. So let's talk about this more technically when dealing with line segments. So if we have a line segment A, B, B, C. So this is a segment from earlier. I'm just lazy. And let's say we have a point in between them. We'll call this point M. And we know M is the midpoint. What can we conclude? Wow. What can we conclude from this diagram? So we can conclude from this diagram, AM is congruent to MB. And why can we conclude this? This is because of the definition of a midpoint. A midpoint divides a line segment into 2 congruent segments. So we have our midpoint and we have our 2 congruent segments, AM and MB. So that's what we can conclude. So that's basically what a midpoint is. So now let's do an algebraic example with it, and then we'll go on to our other one, line distance. Trying to write it out. Wow. So now let's take UHC. UHC. What? Where did I? Okay. And let's set this side to x squared minus 4. Let's set this to... Wait, hold on. So how will we go out solving this? Well, first, let me write something. H is the midpoint. I forgot to write that. So if H is the midpoint, what does this tell us? This tells us UH is congruent to HC. That also tells us UH equals HC. And UH, we know, equals x squared minus 4x. HC equals 5. So we can plug that in, substitute it into our UH equals HC. And now we get x squared minus 4x equals 5. And now we're just solving for x as a normal algebraic thing. X squared minus 4x minus 5. Factoring, we find a common factor. So 1, negative 5, negative 1, 5. Which one of these add up to the b term, negative 4? That equals negative 4. This equals 4. This is negative 4. So here are our 2 factors. X plus 1, x minus 5 equals 0. No, x equals negative 1 and 5. Now, there is a negative x value, but that doesn't mean that it doesn't work. So let me write something out. That doesn't mean we can't use it. So what we do is we plug it into our equation. So first let's plug in negative 1. Negative 1 squared minus 4 times negative 1. 1 plus 4 equals 5. So UH equals 5. That means x equals negative 1 is a viable solution. And what if x equals 5? Let's plug that in. 5 squared minus 4 times 5. 25 minus 20. So 5. So that means x equals negative 1 or 5 are the 2 viable solutions. And here's something you could do if you're not sure if your answer is right. Check. Does UH equal HC? If that is true, then you know that is right because our midpoint divides it into 2 congruent segments. And 5 does equal 5. So there we go. So now let me make another... What did I just do? Let me make another one. This time we're going to be working on the distance. So now we have another line segment. And I'll call this HC. So line segment HC or CH. So let's say we wanted to find the length of the line segment. So there is something. So right now we have a line segment and that isn't on a coordinate plane. So we don't really have points. But that doesn't mean but what if this was on a coordinate plane? And what if we wanted to find the distance between 2 points? So let me draw another beautiful coordinate plane. Okay, so here are our 2 points. And again, let's number them x1, or yes, x2. A lot of formulas dealing with coordinate plane does have to do with subscripts. So that's why you usually name it like that. So here, this is 3, 5. Here, this is x1, y1, or 1, 2. Oh, 1, 2 again. Isn't that amazing? Okay, but anyways, why don't we find the length of the segment now? Or the distance between the 2 points. Whatever you want to say. So the formula to find the distance between 2 points is this. X minus x squared plus y minus y squared. Now, before you say that's 0, let me add the subscripts. x2 minus x1 squared, y2 minus y1 squared. Now, if you really look at this, it doesn't matter if it's x1 minus x2 or x2 minus x1, because they're both being squared. But this is a formula. There might be a counter example, which I don't know about, where this wouldn't be the case. So yeah, always use a formula as directed, which is this. So now we're just plugging the values in of the points. So this is, what is that? So this is the square root of, sorry, 3 minus 1 squared plus 5 minus 2 squared. Now we're just solving. Square root of 2 squared plus 3 squared. 4 plus 9. Square root of 13. And this is our value. So the distance between points A and B is the square root of 13. And also, when dealing with radicals in geometry, make sure you know how to simplify radicals. I mean, I'm pretty sure that is going to be reviewed, but especially for, trig geometry, mostly triangles, really. Mostly triangles. That's where you usually use that, I think. But it's going to be simplifying radicals usually. If they ask for an exact answer, by the way, then they're talking about radicals. If they ask for decimal, then they're obviously talking about decimal. So now let's have an algebraic example with line segments. So we have segment AB. X minus 4, 3x. Oh yeah, I forgot to say something earlier. Okay, we have a congruent line segment. Another way to show that they're congruent each other without explicitly stating it is just little markings like these. These little tick marks are congruency markings. So that would tell us AB is congruent to BC. That also means B is the midpoint. So over here, we don't have congruency markings and nothing says they're a midpoint. So this means, this is telling us that they're not congruent to each other. A is not congruent to B, and I almost dropped that. But we have a length, and this is where we're coming up with the segment addition postulate. So the segment addition postulate is something you really should understand because it's really useful, especially in cases like this. That basically says, given segment AB with point in between AC plus CB equals AB. And what this is saying in this case is, given a line segment in this case, it would say AM plus MB equals AB. So the segment addition postulate says you're given a segment, there's a point in between the segment, and let's say the 2 points on the end points A and B, in the middle and the points in between is point C, then I'll be saying AC plus CB equals AB. And now let's talk about a postulate. What exactly is a postulate? A postulate is actually really simple to understand. A postulate is just something that cannot be proven true, but it is assumed. So you cannot prove that the segment addition postulate is true, but it is assumed true. So that's what a postulate is. So now we're going to be using the segment addition postulate to solve this. So why don't we make some variables? What the flip? Okay. AM plus MB equals AB, and this is because of the segment addition postulate. Now we are given the values of each. AM, wow, I want a different color. What the flip? Okay, it's not shade color. I don't know what it's doing. AM, MB. Oh, is that not doing it? AM plus MB equals AB. So x minus 4 plus 3x equals 12. Let me bring this down here. X minus 4 plus 3x equals 12. So let's solve. Common terms. 4x minus 4 equals 12. 4x equals 16. Kind of scribbling through it. Definitely not because I'm lazy. Oh, now it works. And we divide by 4. X equals 4. So now we got to see if this is truly correct. And we could do it by plugging it in to the equation. So 4x minus 4 plus 3 times 4 equals 12. These cancel out. Sorry, 4 minus 4. These cancel out, and we just get 12 equals 12. That is correct. So that tells us x equals 4. And what if we wanted to find the length of each side? Well, this side's 12, that side's 0. So, yeah, but that's basically it. That's how you use the distance formula. Well, that's how you use understanding length of segments to solve for variables. The reason I group these together is because distance and the length of a segment are closely related. So if you have any questions, leave them in the comments below. And next video will be on angles. So there's that. Make sure to keep studying and stuff. So see ya.